BSides DC would like to thank all of our sponsors, and a special thank you to all of our speakers, volunteers, and organizers.
Good afternoon, everybody. Thank you so much for coming to my talk today. As you can see, I love Halloween, so I've made my slides a little fun and festive for you today. Okay, so just a brief thing. Oops, I won't do that again. I'm from Toronto, Canada. I work in threat intel with a major Canadian bank. I'm also a founding member of the Diana Initiative. We run a conference in Vegas every year to support women in technology and security and diversity in tech. I'm also a member of something called the C3X, where we run cyber simulations for college students. This was our third grade year. And you can find me on Twitter as Encrypted. Okay, the obligatory disclaimer: the views expressed here are mine alone, not those of my employer. Ooh, okay, sorry, my clicker is not clicking. So this talk is about us taking a big picture view of the threats to our enterprise, the threats and the risk, in fact, to our enterprises and their attack surfaces, because we need to see what we're missing, and we need to identify the gaps based on our current regulations and security policy frameworks. So my hope is that I can give you some takeaways and a better understanding of IoT and ET within our enterprise environments in terms of definition and threats and attacks. And I'd like to give you some recommendations that you can take away with you so that you can better secure the policies and frameworks you've currently got in place and enhance your own security policies. All right, so let's talk about EOT, or IoT in the enterprise. Now, everybody here, I'm assuming, does know what IoT is. So ET is just that. It's in the enterprise realm, the enterprise of things. And it's a term that's been around for a while. However, it's not one that we use nearly enough. Essentially, it's what happens when we bring all the stuff that connects into our organizations and our enterprise networks. I want you to think about that for a second. Because we've really got a handle on this IoT stuff, right? Not a chance. And that's why I'm here, because there is a lot that we need to talk about. So according to Gartner, all of those things that connect are going to double between 2018 and 2020, which is next year, as the old tech is replaced with the new, and that enterprises and automotive IoT market is going to grow to this 5.8 billion endpoints, and that's a lot of endpoints. So what do you think that's going to include? Well, we've got utilities, right? We've got smart cars. We've got monitoring. We've got security systems, intruder detection, indoor surveillance, building automation. Never mind all of the other good things that we rely on. There's the convenience things. Lighting, smart lighting. We've got a lot of stuff with a lot of benefits that are perceived. However, we want that, but as the saying goes, be careful what you wish for. So everybody remembers the story of the Sorcerer's Apprentice, right? He wanted to simplify his chores. He used a spell. He didn't really understand what he was doing, and things got out of hand very quickly. Well, the same analogy applies when we're talking about enterprise of things. Quite frankly, we really don't understand what it is we're doing. And yet, here we are, bringing more and more IoT devices in without actually having a plan or the security in place. Right now, the biggest users of IoT with the greatest projected growth are manufacturing, of course, transportation, and utilities. Now I'm going to throw another big number out at you. Let's talk about all the data that we're producing. Over 90% of that data in the world has been produced over the past 2 years. Anybody want to take a guess, just a wild guess, at what our current output in terms of bytes is per day? I didn't even know this was a number. 2.5 quintillion bytes a day. That's a heck of a lot of data. And we just keep making more of it. So, when the Internet of Things becomes the enterprise of things, the attack surface grows, and so does our liability with that. What does it look like? Well, essentially, it's some operational tech, and that is what's tied to helping businesses achieve their goals and the outcomes in terms of profit. So, if we want to look at manufacturing, that includes automation, robots on the floor, sensors and scanners. There's healthcare, which relies increasingly on this, not only to help it manage the costs, but in terms of delivering higher quality patient care and experience. Some of the really good things that means are doing remote medicine and reaching patients in the north, far away from available medical facilities. That's a really important thing. There are pumps. There are MRI machines. I know I've relied on these things. I know people who are relying on these things. There's patient monitors. Now, I've been privy to hear some excellent talks about medical equipment and the security risks, and this continues to grow as a concern. You may not know this, but there could be up to 15 devices, 15 connected devices per one patient bed. Then there's businesses and corporations who use smart TVs and digital conferencing, and don't forget the printers and scanners. And retail, of course, which has to use this everywhere because they need to not only just scan in the information, but now we have automated kiosks. At the CVS, like a couple of blocks over, there's 3 of these independent kiosks, and you're going to see more and more of those. You may be standing in line at Target and suddenly a message pops up. That's because they're utilizing this to pump out the information to get you to buy more goods. They also use it to track the inventory on the shelves and to monitor for loss prevention and theft. And then, of course, there's digital displays, which can be fun to play with. Transportation and logistics, warehousing and transport trucks. This is a huge industry because we have to get our cereal from spot A to spot B. All of the things have to be delivered, monitored, protected. So not only are we scanning what goes in and out of the warehouses to make sure that there's enough supply and just-in-time inventory, but it's monitoring those trucks. And some of those are refrigeration trucks, right? To keep seafood, etc., perishable items safe for consumption. They also help the trucks in terms of tracking fuel consumption, location, rerouting in case there's an accident down the road or bad weather conditions, checking on delivery times. There are wearables which enable employees to communicate more effectively with one another. And then, of course, there's buildings and facility management. We've got HVAC systems, locks, physical security, monitoring. In other words, that's a whole lot of vulnerability that's just waiting to happen. So, this is my first and main takeaway for you right now. We're not spending as much as we're buying, and we're not putting that security in place. If the greatest projected sources for endpoint electronics revenue in 2020 are going to be consumer-connected cars and networked printing, all I can say is we are so hacked. All right, we all know what the road to hell is paved with, don't we? So just about a year ago, I heard a talk by Christine Gladsby. She's the head of product security operations with BlackBerry and she was talking about how the Internet of Things has grown exponentially. No secret, we definitely know that. Not just within the consumer space, but specifically within enterprise. And enterprises want to use all of these fabulous, innovative new endpoints for potential business value, right? And it's opportunity, and it's growth, and it can help create organizational efficiencies. This is all the kind of stuff that business wants to achieve. And if you're aligned with the business goals, you also want to achieve these. It's a combination of what's coming in through literally billions of sensors and sophisticated algorithms for analysis. And this is supposed to help streamline business processes, increase productivity, and then develop leading edge products because innovation. However, with great reward comes great risk as we continue to venture further into uncharted technologies. And face it, we really do not know what we think we know when it comes to IoT, especially when we bring it into enterprise environments. So what is it that we are not considering? What is it that we haven't thought of? For example, how many of these devices can actually listen to us? Now, another factor, we still don't have a handle on cloud, but that's the home of IoT. We face serious capability gaps when it comes to integrating IoT into business. Companies are not taking a holistic or a big picture view, but they're just focusing on one enterprise IoT program. And what happens is that leaves out organizational capabilities and change management, which you need when you are doing any kind of a large-scale rollout or initiative. Those are the checks that help keep us in place. So, even with all that we know about inherent security risks in IoT, and as targeted ransomware attacks significantly increased across 2019, try 118% increase from 2018, there are no real regulations or enforcement to ensure security. So let's talk about what we think we know. To understand enterprise of things, we kind of have to understand the Internet of Things. And I'll start with this drawing. Are people familiar with the... Exactly. Everybody has a different definition of the same thing. Well, that leaves us with what this is not. Surprise, this isn't IoT. Now, they say that a picture's worth 1,000 words, and so I will give you this. What you see here is a lot of devices, different firmware, different products. There are different protocols, different third-party APIs. Essentially, that is risk. That is vulnerability waiting to happen. So simply put, IoT devices are typically non-internet items that have been enabled to connect, to enable them to communicate with other devices online. And that coin was officially termed, that term was coined by Kevin Aston, of MIT back in 1999. So it's been around for a while. There are different flavors, of course, of IoT. There is industrial IoT, and there is the Internet of Health Things, and then there, of course, is enterprise IoT. What it is technology that communicates either machine to machine or mobile to mobile. And it means, in whatever flavor that you care to describe it, it's extending that internet connectivity to ordinary physical devices. And I keep emphasizing that because these were things that were not initially designed to communicate with the network. So we're enabling them to connect and communicate with other similar devices. And what we're doing in that sense is we're going beyond our defined security boundaries to allow connections to devices. And then we, the humans, are taking ourselves out of that equation. And let me leave that concept with you. So, what are unmanaged endpoints? This is what IoT devices essentially can be. Well, they are the things that don't have any security built in. Not security that we can manage and better configure. Think plug and play, for example. Because convenience, my friends, has become the root of all evil. And so many IoT devices are actually unmanaged systems that are able to communicate with other devices and systems within enterprise organizations. Your organization. They process and transmit information. They have an operating system, however simple that might be, and they cannot be managed by traditional security tools that we have in place. But a lot of people think they can. We don't get to configure them. We can't make them better than they are. We're stuck with what we get. So, yeah, what could go wrong? Well, let's start with refrigeration on transport trucks. And you've got a load of shrimp going to your local seafood store. And the temperature control fails, but it doesn't alert the driver. And he shows up at the door, and the shrimp is disgusting. Well, that's a loss you can measure in dollars. But what about when it's a loss you have to measure in terms of life? What about HVAC systems in the buildings where we work, where we live, or the hotels that we get to stay at? Is anybody familiar with Legionnaire's disease? There are outbreaks. And if you're relying on controlled, monitored systems to ensure that ventilation is clean and air conditioning is running properly, and those fail, and the bacteria develops and builds up, and it's not being tested for, and you can't monitor everything, you can have an outbreak of Legionnaire's disease or something similar. Think in terms of quality control for food we eat or medicines that we use. What if those controls are not working properly, or we can't see end-to-end to ensure that something isn't in there and interfering with that transmission process? If those controls were tampered with, how would we know? Now, I might be a little paranoid here, but we have seen ransomware very active in our hospitals. It's an ongoing situation. The fact is we rely on these devices to be reliable and to notify us. In other words, we trust them. And what is that cardinal rule about trust for those of us in InfoSec? Trust nothing. Trust but verify. Okay, so there's a lot that we don't get right. Is anybody here a baker? When you're baking and you've got a great recipe for birthday cake and you can make maybe double it up and make like a second batch of cupcakes for the class fair, it's okay, it works really well. But that does not scale to 10,000 cupcakes. You are not going to get anything near that original cupcake recipe if you try this. Same thing applies. And hyperconnectivity, because we have to connect all of the things all of the time. And that consumer-driven need for things has just made itself right at home in our enterprise environments. We're dealing with a rush to market, right? We're dealing with the need to be innovative and ahead of our competitors. So we don't have security in our software-defined life cycles the way we need to. We face supply chain risk and the possibility for the liability. So devices get shipped that cannot be updated or are really difficult to update. And risk gets pushed along that supply chain so that whoever buys it owns it. And consumers wind up bearing that security maturity issue for the enterprise of things. According to a Ponemon survey done back in March of 2017, most organizations were not inventorying IoT devices because they just didn't have centralized control over the devices that were coming into their workplace, along with the apps needed. You know what that can lead to? Shadow IT. How many people here are familiar with the term? Do I need to explain? Okay, good. Now, I have a question. How are you inventorying the personal devices used by your staff or your employees for bring your own thing, IoT? You might have BYO device to some extent, but a lot of stuff is coming in that is IoT, that is getting plugged into the networks, and it is staggering to see what is actually on there that should not be on there and cannot be seen. So I'm going to leave you with this concept. Just one of those devices compromised offers lateral movement within the networks for an attacker. Okay, so let's consider this an open invitation to shadow IoT through increasing unmonitored and unsanctioned BYOD. And as IoT continues to move further into our enterprise realms, shadow IT becomes shadow IoT becomes shadow ET, and we have new challenges and risks that our current frameworks do not address. So here's another worry for you. How does your current security policy and SLA address IoT with your trusted third parties? This really doesn't appear on a lot of agreements, and it needs to. So the R thing, in an article from CSO from 2018, 97% of risk professionals said that a data breach or a cyber attack caused by unsecure IoT devices could prove catastrophic to their organization. Well, that's cause for concern. And I'm going to use this as an analogy. IT teams in hospitals do not have the visibility to see how many devices that are IoT or what types of medical devices are actually on their networks. I think that that translates to any organization. Unless you're actively monitoring for it, unless you've actually set up the configurations to identify it, you really don't know what's on there and what's out there. As well, you don't have an appreciation or an understanding of the risks and vulnerabilities of these types of devices. We are used to working with conventional equipment and sanctioned and approved network devices within our enterprise environments. But these devices are also getting attacked for their access to data. And they can reveal all of the valuable stuff, financial, health, personal. But they can also be leveraged for ransomware, pulled into botnets, or potentially worse. So here are our takeaways. We've identified what makes ET different from others. We know about the ongoing and increased risk to shadow IT as it becomes shadow EOT. And then what we need to have happen is a shared corporate responsibility across multiple layers of management to be responsible for this. So now that we know what it is, and we care, how does it work? This will be just a really quick step through. I am leaving a lot of stuff out because this is not a course on what IoT is. I'm going to ask that you think of it in terms of 3 layers. First level, of course, are the devices, the things. These are sensors and actuators, and that's pretty much the realm of it. They're sitting at the edge, and they're gathering all of the data. And then they're able to action it, and they send it up using an IoT gateway to the cloud. They typically communicate through either wire or through radio frequency. Now, some devices come ready to go out of the box. Others are more legacy or older equipment, and these connect through analog or serial connections. And they get connected to things like microcontrollers There are systems on modules known as SOMs, or there's single board computers called SBCs. And these utilize devices like we're familiar with Arduinos or Raspberry Pis. Next we have the IoT gateways, and these act as our middlemen to both serve as a messenger and a translator between the cloud and the smart device clusters. So we've got a lot of physical devices or software programs working alongside that, and what they need to do is they normalize, connect, and transfer the data between the physical device and the cloud, and that is a ton of raw data that has to be filtered and processed. So a lot of these are now being enhanced with additional capabilities to do just that, to filter through the data and make it more useful and take out a bunch of the stuff that nobody can or wants to have to use. It's designed to help address, we saw that previous slide, with multiple protocols that are out there, to connect with AI, to do some pre-processing, to help us do provisioning and device management. As well, more of these devices are being equipped for data encryption. And that is a huge thing. Ideally, what we want to see is encryption of the data from end to end, whether it is in transit or at rest. And then, as well, offering some degree of security monitoring. Last but not least is the application layer via the cloud. So we need a huge place to store all of this data and a place with a ton of processing power, hence the cloud. And this is all about big data. So we have got storage, filtering, data analytics, as well as the alerts and monitoring. Bless you. So wireless sensors and actuators work together. They provide that connection between the digital and the physical worlds. If the sensor's collecting the information, passing them on to the actuators. So if I was going to use an example for you, I could use a cell phone. On your cell phone, you've got a camera and a mic. These are inputs, and they take in, obviously, visual as well as audio data. The speaker and your screen act as the actuators to turn that into actionable information for you. So how many sensors are out there? Billions. Billions of them. The average home actually has enough to fill more than 332 gigabyte iPhones. And much of that information, as I said earlier, is raw and it needs to be filtered out. It's literally not usable. For example, in a report from a gas rig, the managers were only able to use 1% from a ship's 30,000 sensors to do maintenance planning. So on average, they're saying that companies are using maybe 10% of all the information they're taking in. Another important point is that actuators can produce physical changes based on the information that they get from the sensors. They actually make a decision and do something. They can move something or shut off a device. So think back to when we were talking about handing over control to the machines and what could go wrong. There are 4 types of communications between the devices. There's the device to device, basically using things like Bluetooth or Zigbee to communicate with each other. There's the device to the cloud, talking up through that gateway. There's the device to the gateway, again, just going straight to the gateway. And finally, there's cloud to cloud. So that's within the architecture, and you have APIs and software. When we're talking about IoT architecture, these are essentially the requirements that we are striving for to build in and support, because you need to be able to do good data collection, have it efficiently handled so that you can minimize the raw data coming in and put together usable output. Connectivity and communications, because not only do you have to connect to that network, but you want it to be flexible and robust in terms of the protocols that it will support. Scalable, of course. We want security, ideally end-to-end encryption and monitoring. We want both availability and quality of service, because we want to limit the downtime and have it fault tolerant. It needs to be modular and flexible and platform independent, because it's going to be working across a huge range of things and territories. Each layer ideally is going to allow you to add different features, different hardware, and cloud infrastructures from a variety of suppliers and manufacturers. You want it to conform to open standards and be interoperable. And then for device management, you want to enable automated and remote device management so that you can get things like automatic updates. You also want to have defined APIs within each layer to allow for easy integration. And that brings us here. We have to integrate all of this fast-moving and evolving tech into established constraints. Welcome to enterprise architecture. So think of enterprise architecture, or EA, as urban planning for systems. It's for systems, for networks, for integrations. All of the things have to live somewhere. So while systems engineering is essentially for one component, like a building, EA is for the community. And the challenge comes from trying to incorporate all of that new technology from IoT into the existing and even legacy systems of enterprise architecture. So terms like rigid and traditional can apply here. And the fact is, these are not systems that are designed for speed or agility. They are in place because they're solid and they're secure and they're looking at a different, bigger picture. IoT is about innovation, and you want to be able to move quickly and rapidly and enhance what you've already got and keep building on it. That's not the goal of enterprise architecture. Enterprise architecture has to address existing security concerns, manageability, and interoperability. Now it has to also do this in conjunction with IoT so that it doesn't inhibit an organization's ability to innovate or operate. You can see where the challenge is. So if we're looking at those principles, what did I leave out? What word never got mentioned in there? Somehow security gets left off this list. A lot. This is kind of what it looks like. This is actually what it looks like. So you're bringing data across 3 different networks with a variety of protocols, requirements, firmware, and hardware. Which brings us to our takeaways. We've got 3 different layers of architecture to consider: the physical, the internet gateway, as well as the cloud. Billions of devices out there, the sensors and the actuators, that can even produce a change. How we are monitoring the data across 3 different networks, and the integration issues when you try to bring IoT into existing enterprise architecture. So how is it that IoT attacks are different? Let's start here, please. We're used to talking about conventional attacks in terms, or breaches even, in terms of being focused on data exfiltration for identity theft and credit card theft and monetization. In the IoT world, there is some of that, but really these connected devices have more riding on them. They run things that we rely on. They work often in mission-critical environments, critical infrastructure. So the attackers can turn the devices against the company, and it becomes about disruption or destruction. And the impact is measured in terms of damage more than it is dollars. And that presents a challenge of securing beyond what we know as the CIA triangle. Attackers can carry out man-in-the-middle attacks, spoofing, cloning, software attacks that will steal credentials, and encryption attacks against key algorithms. Now, this information is from the Erdetto Global Report from May of this year. There was a survey of 700 enterprises across 5 countries, which included the UK and the US. And they stated a distinct lack of optimism about the future security of IoT devices in these organizations. 82% of these organizations that manufacture IoT devices are concerned that the devices they develop are not adequately secured against a cyber attack. That's a pretty sobering statement. And in the UK, Germany, and China, all of which are very large producers of things, 100% of the IoT device users felt that the security of the devices they had could be improved to a great extent, which is an alarming finding considering how much they're putting out. Now, 49% of these organizations were making security part of their SDLC process. And about 53% conducted continuous security or code reviews. That sounds like a good number until I say it only takes one. So just take a look at these stats and think about your own organization and what you might answer if you were asked these questions. What are your firmware updates in your policies for security? Are they automated? How about default configurations? Do you check all of the devices coming in? And do you look for backdoors, which can also have default configurations? Things like universal plug and play, open ports. So this past April, Microsoft's Threat Intelligence Center discovered a targeted attack by an advanced attacker known as Strontium, APT28 out of Russia, against IoT devices. Involved was a VoIP phone system, printer, and a video decoder. And the attack hit multiple locations. It used the devices as access points into the wider corporate network. That's a huge risk for any enterprise. Now, 2 of these 3 devices still carried the factory settings, and the software on the 3rd one had not been updated. Points of ingress will lead to further access. So, I work in threat intel, and we like to follow the games that nation states play. They target critical infrastructure. Who here has not heard of Stuxnet? Exactly. But there are other destructive and targeted malwares out there, like Shamoon, for example, and more recently, Triton. International economic sanctions provoke retaliation, which we have observed very recently with both Iran and North Korea. And they have demonstrated their capability with destructive malware and cyber attacks. Thanks to the release of Mirai source code from just a couple of years ago, we have a plethora of botnets out there that have been weaponized and pose a real threat. This is not about monetization. This is about power and control. And what are the consequences of ignorance or inaction? This is more from that Forrester survey. So unmanaged and enterprise of thing devices are far more vulnerable to attack than conventional devices on the network. We cannot apply our same attack scenarios and threat models to these devices. And what we need to evaluate is what do we have in place? Because once they get in, attackers can leverage and then they can pivot and go further into our networks. Which brings me to this. It's because it only takes one. These are some attack vectors. Yes, printers. Printers are a big risk. You would be surprised. HVAC, anything that you can compromise can be leveraged as a point in. We have increasing risk through crypto miners. Once somebody gets into your network, they're in your network. It doesn't matter if they came there to mine. They stayed there to do more. We talked about the increase in ransomware over 2019, targeted attacks on industry. Norsk Hydro, for example, $60 billion and counting. That's a lot of money to spend to try and get back up. Pitney Bowes got hit and hit hard. Silex Malware was discovered in June of 2019. In a space of hours, it bricked 2,000 IoT devices. It wiped their firmware, it trashed the storage, it dropped the firewall rules, it removed network configuration, and it halted the device. It pretty much stopped short of frying the circuits. This is similar to something known as BrickerBot, which hit back in April of 2017 and ran through till December of that year, and reportedly affected 10 million devices. So you could reinstall the firmware, but the reality is you won't, because it's that hard. And chances are you may not even recognize this as malware and just throw the device out. So this year, again, millions of first generation Amazon Echo devices. How many people here by chance use an Amazon Echo? Or 8th generation Amazon Kindle devices? How many have a Kindle? Yeah. Are vulnerable to something called a key reinstallation attack, or crack. This is a four-way handshake vulnerability in the network, and it was identified in October of 2017. These are the 2 CVE codes that are associated with it. Well, it came to light that actually these vulnerabilities exist in these devices, and they can be exploited by attackers to conduct man-in-the-middle attacks against WPA2 protected networks. A lot of average consumers are going to just click right on that WPA2 button because it's a button and it's easy. Boom, I'm secured. Unfortunately, no. And you can go into these supposedly protected networks and steal information from the targeted devices and decrypt the packets sent by the clients via plain text. So you can see denial of service attacks result, a disruption to network communications, replay attacks. There's potential for greater. Okay, who hasn't had a Polycom experience at your organization? It's ubiquitous, right? But this is what we do. I don't know about you, but my organization has cut travel spending, and this is what we rely on, is teleconferencing. There are a lot of endpoints in these systems. Well, the attackers know about these. They know that there are vulnerabilities. And with all of those endpoints, the fact is each one is an opportunity into your network. Who implements these in your organization? Typically, it's somebody who's familiar with audiovisual equipment. It's not the security team. That's not going to be something that's on the checklist. So, Polycom HDX had a significant vulnerability that was actually being exploited. And these Polycom systems, they're linked to each other across different corporations globally. Just think about that for a second, across the globe. And the risk of this is that through these unified communications devices, which often still have their default passwords or pins in place for use, it just takes one to infect the whole system. Urgent 11, has anybody heard about this? Because this was just recently announced. This is a very significant set of 6 vulnerabilities that can lead to remote code execution. There's a huge range of the affected versions that span across 13 years. And there are a lot of manufacturers who use this as their operating system. Attackers can effectively circumvent the NAT and firewalls to control these devices remotely via the TCP IP stack, undetected, because the vulnerabilities have a low-level position in the stack. They're just seen as harmless communication. That's what they're showing up as. And there's no user interaction required. So the vulnerabilities don't require any adaptations to the devices. And it spreads very, very easily. Here are just some of the devices that are impacted, and some of the huge manufacturers. We all use things from these companies in enterprise systems, and this affects everybody. There are proof of concepts for these attacks by Armis online. This, for example, is against a sonic firewall. I used to work for a managed service provider that put sonic walls in because firewalls are supposed to be your line of defense. They're not supposed to be vulnerable, but they are. And an attacker can take over this sonic firewall via Urgent 11, and then they use a specially crafted TCP packet to take over all of the firewalls. In another instance, any of these connected devices can be taken over by an attacker to get in and to compromise your network. Here are our takeaways. Which brings us to this. We need to make it better. Who's seen the movie iRobot? Exactly. It was good until it wasn't good, right? And that about sums it up when we have IoT infiltrating enterprise systems. These devices are not the obedient little soldiers that computers and laptops are. They interact differently with the network, and they behave differently. And they operate with little to no human intervention, because we've taken ourselves out of that equation. So I'm just going to say this. Automating convenience with inadequate supervision is just going to end badly. So how do we make it better? This whole section is a takeaway for you. Know your attack surface, operating systems, software, liability reduction. Please use strong authentication in conjunction with good passwords. Check for the defaults and remove them. Network segmentation. You got to keep them separated. Give them their own space. Set them up on a private VLAN, their own portion of the network. Firewalls and VPNs, because you got to go through me first. Automation. You can't do this the way you're used to doing it anymore. You really have to automate for visibility, because you need visibility, and you need to be able to identify currently everything that's on your network, in your network, and establish baselines, and then be able to update it regularly. Have centralized access logs, which will help your IT team. Know your baseline and then monitor for anomalies. This. We need to put rules in place. Businesses need to be clear about what they're using, how they're using it, why they're using it, and then set that up with policies and enforcements. Yes, we need to use automation to help us do this better. We need to classify our devices in terms of how they're going to be used and who's going to use them and who is going to have access and give that authorization accordingly. We can utilize frameworks in NIST and CIS that actually address IoT. We can develop a better comprehensive IoT security policy. Data encryption all the time, and have a mature software-defined lifecycle. If you need help, you can find things like this online to get that framework in place for you. Big takeaways: know your normal so you can monitor for those anomalies, and automate. There's even this, zero trust privilege, that will move us past existing approaches to privileged access management. So let's recap. We need budgets. Let's spend some time and money to control unmanaged and IoT device security. Put them in their own place. Invest in the people, policies, and procedures across your organization. Invest in automation so you have the visibility. Collaborate, work together, get out of the silos and share the information. And make a good security policy. And that is it. And I thank you very much for your time and attention today.
Thank you, Cheryl. We've got time for one quick question, so if there is one, raise your, any questions at all?
So where's the trend? So there's a lot of companies getting into IoT. There's huge demand for the devices, but for a number of years, we've been saying these things are not secure. These things shouldn't be part of the network. So are things getting better, or are things getting worse?
Things are getting, I believe things are getting worse because we're outnumbered by those devices. We do not have policies in place. We don't fully understand what we're using, and we are not really secure yet in the cloud where a lot of this is going. The volume of data that we're producing and we're losing through things like misconfiguration, every week it's another Elasticsearch database or Mongo database that's exposed with 180 million records because of misconfiguration. We are not there yet. That would be my answer. Sorry. Okay.
Okay.
Thank
Thank you,
you.
everyone.